Hey, I just want to make this quick little video going over some concepts in fractions. So the goals in this video are to be able to estimate fractions using benchmark fractions, order fractions in ascending order, and compare fractions. It's not going to be that extensive going over those concepts, but just kind of introductory in some ways to think about it. So the first thing I want to show you is like how to set up a number line using fourths and just how that might look with fractions. So like you have a 0 and a 1. I always usually like to split it in half first and estimate that, and then I cut the halves in half. And then so you have 1/4, 2/4, or it can be, this is also 1/2. Those are equal. And then 3/4. Obviously this is not, I think, if I could redraw this, maybe draw it like over here somewhere. But yeah, okay, so you get the idea. That's how you would draw fractions. And the fourths are an example of a benchmark fraction you can use to kind of estimate other fractions and pair them. Over here we have how to estimate fractions by using benchmark fractions. I put on the number line some. I put 1/4, 1/3, 1/2, 2/3, 1/4, and so you can kind of see, and even a whole, I would consider that like it might be closer to a whole. Oh, this is incorrect. I thought I could fix that. It should be a 3/4, because it's 3/4 there, not 1/4. Anyways, so I want to like point out how you would figure out, okay, 4/9. Well, where might 4/9 be? Well, you can always like draw a number line, like, oh, let's draw this number line here. Okay, 9ths, so 9 equal parts. Oh my goodness, that's going to be tough to do. Well, wait a minute. I know that 4/8 is close to 1/2, and 4 times 2 is 8. So since that's like close there, but I know more than 4 would need to be half of 4/9. I know that 4/9 is probably a little bit less than 1/2, so it's just like probably right about in here somewhere. But we use 1/2 to know it's a little bit less than half, not quite there, because 4/8 would equal 1/2. 4/9 is going to be smaller than that. 5/6. Now drawing 6 wouldn't be too bad, because you're really just kind of like, oh, let me just put a line here in my thirds, and half would be 3/6, and then just go split this third in half, and you're like, oh, 5/6 would be right here. But another thing to think of 5/6 is that you're one fraction away from the whole. One more would give you 6/6, so you know that you're pretty close to 1. So you're going to be somewhere in this area. And again, we're estimating. We don't need the exact place of it. 9/20 is another one that's like 4/9, where you're sitting there thinking, oh, if I had 20 equal spots, well, I know 10 would be halfway, so 10/20 is half, and 9/20 is close to half, so 9/20 would fall right about, 1/2, and it's going to be a little bit less, because 10/20 is 1/2. Yep, that's all the ones I had on that one. And so now I'm comparing fractions. This is just going to talk you through how I'd think in my head, maybe draw a diagram or something if I need it. So I'm sitting here looking at 11/12 and 5/9. I'm thinking, how can I compare that? Well, 5/9 is similar to 4/9, except it's a little bit bigger. 5 times 2 is 10, so this is a little more than 1/2 here. Here it'd be a little more than 1/2. And then 11/12, well, 12/12 would be 1, so this is pretty close to 1. That means that 11/12 is going to be greater than 5/9. It's close to 1, 5/9 is closer to half. Looking at 5/9 again down here, and then 5/7. Well, what I can tell you is when you have the same numerator, look at your denominators. I have 5 and 5, but this is 5/7, and out of a whole, 7 pieces means that each piece is going to be bigger. If the whole is cut into 9 pieces, the pieces will be smaller. I always think of like pizza. If I had a pizza and cut it into 9 equal pieces, 5 pieces would be smaller than if I had the pizza and cut it into 7. You'd rather, if you want more of something, you'd rather only share with 7 people than share with 9. So I know that 5/7, and 7ths are a bigger fraction size-wise. 5/7 is going to be the greater one, or 5/9 is less than 5/7. And then 7/13 and 5/11. This one's tricky, because 7 times 2 is going to be 14. So that would be 7/14 would be half. So that means that this is close to half, okay? Close to half. And then 5/11, 5 times 2 would equal 10. So 5/10 would be half. This is close. So they're close. So you got to really think which one is bigger than 1/2, which one is less. Notice how 7 times 2 is 14, and 14 is greater than 13. That means that 7/13 is actually going to be bigger than 1/2. So 7/13 is larger than 1/2. And this one here, 5 times 2 is 10, and 10 is smaller than 11. So 5/11 would be smaller than 1/2. So we know 5/11 is just less than 1/2, and 7/13 is just more than a half. So 7/13 ends up being slightly greater than 5/11 based on that reasoning. Finally, we end here on, there we go. We want to order fractions in ascending order. I'm going to just write these over to the side. Now I'll find a spot to write them. So let's zoom in here, just focus on this top row. 1/8, 1/11, 1/9, 1/4, 1/7, 1/5. Remember I told you where if the numerator is all the same, you can just like put the denominators, the bigger the denominator, the smaller the number. So that makes 1/4 the biggest fraction here, and we put the biggest, but again, we want to do ascending order, and that means increasing. So we start with the smallest. We'll start here with 1/11, and then we count down. Okay, we have 1/9, then we have 1/8, and then 7th, 1/7, 1/5, and 1/4. Same type of problem down here with the 4/5, 4/10, 4/12, 4/7. If you feel comfortable with this, go ahead, pause the video, try and do it, and hit play and watch me solve them. So if you've solved it, let's go ahead and check. You're looking at the same numerator. We've got to get the smallest one, which means smallest pieces are going to be 12ths, so 4/12, and then 4/10. And then the next one is 7ths, 4/7, and then finally 4/5. And that would be an ascending order there. Now this one's tricky because we have both different numerators and different denominators, so it's more challenging to compare. The first thing you want to think is, okay, ascending order. Well, I noticed 10/11, so 10 is pretty close to 11, so this is going to be our biggest one. That's really close to 1. I'm going to go ahead and write that one over here, 10/11. That's close to 1. And then I look at the other one, 7/13. 7 times 2 is 14, so that's going to be close to a half, and 5 times 2 is 10, so this is going to be close to a half. So this is going to be half, this is going to be half. Man, so I don't know which of these two is bigger yet. 2 7, so you need to have like 3 or 4 7ths to be closer to half. So 2 7ths isn't there, so 2 7ths are going to be our lowest fraction. And then we just have to decide in the middle there, where does 5/9 and 7/13 go? We did compare these earlier in the video. I believe we did. And so 7/13 is going to be just more than a half because 7 times 2 is 14, so 7/14 would be half, meaning that since 14 is greater than 13, the 7/13 is bigger than 1/2, which we'll end up putting that here because 5 times 2 is 10, and then 10 is greater than 9. And oh, wait, no, we didn't do this earlier. This is slightly different. So we're like, this is a tricky one because 5/9 is going to be slightly more than 7 is going to be slightly more than a half, and so is 7/13. So as we're sitting there thinking, okay, they're both a little bit more than a half, and we have to figure out which fraction is closer to a half. So think about it, if 13ths are smaller pieces, so these pieces, since it's 13ths, will be smaller. So if you got to half, but you're only counting by like 13ths, then the 7/13 is only going to be a small way past half, whereas the 9ths are bigger pieces than the 13ths. So the 9ths, the 5/9 will actually cover more space. So since the 7/13 are smaller spaces, we end up putting them here and the 5/9 here. So I'm glad I caught that mistake before I finished this video, but yeah, so this would put these in order, and it's just about kind of logical thinking, how big your pieces are, how they compare, and putting things in order, also based on those benchmark fractions. And as I was comparing these two right in here to half and thinking how close they were to the half, and then how big the pieces were, whether they be bigger or smaller than each other.